Assalamualaikum and a very good morning to all of you. So today I would like to present to you about the introduction to fluid properties. But before we begin, let me introduce myself first. My name is Syafiq Hamzah, and my metric card is 206053. So let's begin our presentation. First is, what is the meaning of the fluid? The fluid is a substance that is having the ability to flow or deform continuously under the action of shear force, no matter how much small the force is. All types of liquids and gases are known as fluid. Example, water, mercury, steam, air, and the others. If fluid is static or stationary, then it means no shear force acting on it. So next is, what is the difference between solid and fluid? For solid, the deformation is constant with respect to time. Meanwhile, for fluid, the deformation is continuously varying with respect to time. For solid, after remove the solid will try to regain their original position back. Meanwhile, for the fluid, it will never try to regain their original position back. Next, solid, all types of deformation are possible, like torsion, bending, longitudinal, and volumetric deformation. Meanwhile, for fluid, only angular deformation is possible. Next, solid also show resistance to all types of fluids. Meanwhile, fluid show resistance to only compressive fluids. Next, so this is all the fluid properties. There is a specific weight, density, surface tension, specific gravity, vapor pressure, and viscosity. Next, we are going to move about the Newtonian fluid and non-Newtonian fluid. So, what is the Newtonian fluid? Newtonian fluid is a fluid with constant velocity at a fixed temperature and pressure. The viscosity is independent on the shear applied to it. Next, it also obeys the Newton's law of viscosity, which is, we can see right here, the formula where the micro is a dynamic viscosity. This one is shear stress, meanwhile du over dy is a velocity gradient. The example that for Newtonian fluid is a water, alcohol, gasoline, and the others. Next, we are going to move to non-Newtonian fluid. Non-Newtonian fluid is a fluid that the viscosity changes based on the shear applied to it. The viscosity is dependent on the shear applied to it. So it also don't obey Newton law of viscosity. There are the major classification of non-Newtonian fluid. There is a two. There is a time-dependent fluid or time-independent fluid. Example for the time-dependent fluid is a thexotrophic fluid and rheopatic fluid. Meanwhile, for example for time-independent fluid is pseudoplastic, dilatant fluid, Bingham fluid. Next, we are going to move about this. This one is the graph for Newtonian fluid, which is they are proportional. And meanwhile, this is a non-Newtonian fluid graph. We can see this Bingham plastic, plastic, Newtonian fluid, lectin. Okay, next we are going to move about the surface strength and elastic modulus. Surface strength. What is surface strength? Surface strength is also known as a surface tension, can be defined as the work per unit area that required to move lower molecules to the surface of the liquid. For the unit of the surface tension is a force per unit length. Meanwhile, for the SI unit is Newton over meter. For US unit is pound over feet. Next, the surface tension formula. The surface tension formula is the work over area. Next, the surface tension is totally depend on the forces of interaction between the solid particles within the given liquid and also upon the gas, solid or liquid in contact with it. For the example of the surface tension is the phenomenon of capillarity. Next, we are going to move back to the elastic modulus. Elastic modulus is a force applied to an object that can change its shape, the response of a material to a given type of deforming force is characterized by an elastic modulus. Elastic modulus formula is the stress over strain, which is the stress is force per unit area. Meanwhile, for the strain is fractional change in dimension or volume. There are three types of elastic modulus. I'm sorry for this typo. For the first one is the Young modulus, which is for solid. The second one is the shear modulus, which is only for solid too. And the third one is the bulk modulus, which is for solid and liquid or fluid. Next, we are going to move to compressibility of fluid and vapor pressure. Compressibility is a measure of the relative volume change of a fluid or solid to a response to a pressure change. The usual quantity used to measure this phenomenon is the bulk modulus of elasticity, or known as bulk modulus, which is E. The unit for this compressibility is Newton over meter square, or Pascal or PSI. Next, the formula for the bulk modulus. Formula for the bulk modulus is the delta P, negative delta P over delta V over V, whereas the V is the volume and the P is pressure. Liquids are generally incompressible, whereas gases are generally highly compressible. Two piston cylinder arranged in shown in figure 1, you can see, is filled with liquid, and other arrangement is filled with gas. This one is with the liquid and this one with the gas. In this case, we can see that the liquid increase the pressure, the volume, and the density remain unchanged. Meanwhile, for the gas, the pressure increase. Meanwhile, for the volume, it start to decrease and the density start to increase. Therefore, liquid is incompressible and gas is compressible. That's the conclusion for this figure. Next, we are going to move to the vapor pressure. Vapor pressure is the pressure exerted by a vapor when the vapor is in equilibrium with the liquid or solid form, or both of the same substances. It is also a measure of tendency of a material to change into the gaseous or vapor state, and it increases with temperature. The temperature at which the vapor pressure at the surface of liquid become equal to the pressure exerted by the surrounding is called the boiling point of the liquid. Vapor pressure is a fluid property and it is functional of the temperature. Generally, the vapor pressure increases with temperature. As an example, we can see a closed container, which is right here, filled with liquid. As the liquid molecule at the surface gains sufficient energy to escape into the air, which is into the evaporation form, some of the liquid molecule will collide with the air or with the air molecule and bounce back to re-enter the liquid, which is the condensation. Over a period of time, the system will reach a steady state where the rate of evaporation is the same as the rate of condensation. At this instant, the pressure exerted on the liquid surface by the liquid vapor is called vapor pressure. Next, dimension and dimensional homogeneity. What is dimension? Dimension is a measure of physical quantity without numerical values, while a unit is a way to assign a number to dimension. For example, the length is a dimension that is required, that is measured in units such as feet, centimeter, meters, kilometer, kilogram, and others. There are 7 primary dimensions, or also called fundamental or basic dimension. There is mass, length, time, pressure, electric current, amount of light, and amount of matter. All non-primary dimensions can be formed by some combination of the 7 primary dimensions. Next, we are going to move to the dimensional homogeneity. What is dimensional homogeneity? Dimensional homogeneity is the concept where the dimension of variable on both sides of the equation are the same. If the units are the same, the dimension of each term must be the same. So right here there is a principle of the dimensional homogeneity, which is it state that every valid equation must be dimensionally homogeneous, which is all additive terms on both sides of the equation must have the same dimension. It also states that all additive terms in a physical equation must have the same dimension. For example, we can see right here there is a 2 apple plus 2 orange. We can see it is possible because it is a different fruit. So it is the same like the principle what the principle of dimensional homogeneity tells us. You can't add orange with apple because it is two different things. It is the same with what the principle of dimensional homogeneity tells us. Next, we are going to move to the dimensional analysis and similarity. Dimensional analysis is a method for reducing the number and complexity of experimental variables which affect a given physical phenomenon by using a sort of compacting technique. It is a pure mathematical technique to establish a relationship between physical quantities involved in a fluid phenomenon by considering their dimension. In dimensional analysis, for a general understanding of fluid phenomena, we first predict the physical parameter that will influence the flow, and then we group this parameter into dimensionless combination which enable better understanding of the flow phenomenon. Dimensional analysis is particularly helpful in experimental work because it provides a guide to those things that significantly influence the phenomenon. Thus, it indicates the direction in which experimental work should go. Next, there are two-dimensional analysis that is used in the Rayleigh method and Buckingham method. There are also three similarity. There is a geometric similarity, kinematic similarity, and dynamic similarity. First of all, we will go to geometric similarity first. Geometric similarity is the ratio of all corresponding length in model and prototype are the same. Meanwhile, kinematic similarity is the ratio of all corresponding length and time in model and prototype are the same. In this way, the velocity scale proportion will be the same for both, that is for model and prototype. Next, dynamic similarity. Dynamic similarity is the ratio of all forces in model and prototype are the same. If dynamic similarity exists, so kinematic similarity also will exist. Next, we are going to go to Buckingham Pi theorem. Buckingham Pi theorem states that if there are n variables in a problem and there's this variable contains m, which is primary dimension, for example, m, l, which is for mass, l for length, t for temperature, the equation relating all the variables will have n minus m dimensionless group. So the final equation will be like n1 equal to f over n2 f multiplied by n2 pi 2 pi 3 and the others and pi n minus m. The pi group must be independent of each other and no one group should be formed by multiplying together powers of others group. There are three methods for us for determining pi. The first method is inspection, and the second method is the very famous method that is a repeating variable method, and the third method is the step-by-step method. So we are going to discuss about the second method that is very famous, that is the repeating variable method. So here is a guideline to solve the dimensional analysis using the second method, which is the repeating variable. First of all, we must list all the variables that are involved in the problem. Next, we need to express each of the variable in terms of basic dimension. Next, we need to determine the required number of items. Then we need to select a number of repeating variables where the number required is equal to the number of reference dimension, usually the same as the number of basic dimension. The fifth step is we need to form the pi term by multiplying one of the non-repeating variable by the product of repeating variables, each raised to an exponent that will make the combination dimensionless. The next step, we need to repeat the step 5 for each of the remaining non-repeating variables. Let's say we have many non-repeating variables, so we have to repeat it until all the non-repeating variable is finished or we don't have anymore. Next, the second last step is we need to check all the resulting items to make sure that they are surely dimensionless. The last step is we need to express the final form as a relationship among the items and think about what is more. Next, it is a dimensionless term. Dimensionless term is a term that frequently used in fluid mechanics, with each dimensionless. There are about seven dimensionless terms that are we frequently use in fluid mechanics. For the first one is Reynolds number, which is RA. It is a dimension, while the dimensionless group is a PV over L over macro, and the interpretational or index of force ratio indicate is an inertial force over viscous force. Next, we have Froude number of or FR. The dimensionless group is V over square root of GL. Meanwhile, it is mean or inertial force over gravitational force. Next, it is a Euler number. The dimensionless group for this Euler number is P, which is a pressure over density times by velocity. Next, the pressure, the force ratio, the index of force ratio indicates that is a pressure force over initial force. Next is a Cauchy number or CA. It is a density times by the velocity square over EV. EV is a bulk modulus, and the index of force ratio indicates inertial force over compressibility force. Next, we have next number is MA. The dimensionless group is V over C, which is velocity over C. C is the speed of sound. And the interpretational is the inertial force of compressibility force, which is the same with the Cauchy number. Next, we have the second last one is the Weber number. Weber number, the or WE, the dimensionless group for this number is a P V square over L over surface tension. The interpretational is the inertial force over surface tension force. The last one is the Strohal number, which is ST. The dimensionless group is the frequency of oscillating flow times by length over over velocity. The interpretational is the inertia or local force over inertia that is a convective force. And this is all my reference, which is the two books. That is this one is a book, and also this one is a book. Meanwhile, the two other is a URL or which I found on the internet. I think that's all presentation for me. I think that's all presentation for me. I would like to stop right here. Thank you.